a moment to talk about working with large documents with AI. I'm going to talk about it in the context of Copilot with SharePoint, but this really applies to any harness model. So think GitHub Copilot, think Copilot Cowork, any of those projects and how they work with files. This is pretty relevant. So when we talk about larger context windows, sometimes folks think that's the best way to get working with larger files, but in reality, you don't ever want, or rarely do you want, the whole file in the context window. Not only is that wasteful, but it adds to the possibility of hallucination in how your model understands. Your bloated context windows are just generally bad. So we're going to talk through sort of how to still work with files and make great use of them while not necessarily overloading the context window. So what do you do? I'm going to leverage this 2,000 plus page bill. This is from 2020. There is a law that was passed that is here. If you look down, 2,124 pages of PDF content. This is a giant PDF file and estimating about 4 million tokens if I was to say read this whole document end to end. I have a 1 million token context window to work with. It's 4x capacity, but again, that's without actually doing anything, and it's really wasteful and will lead to bad results if I try to see the whole document. And so instead, what we're going to do is we're going to leverage some of the tools under the hood. These are tools that if you're a Linux or Unix nerd, you'll remember, but things like grep, you have the ability to use semantic search, and you can write code. And using those things, you can actually answer really hard questions about files of this size without actually needing to read the whole thing into the AI. So let's do some examples, and then we'll talk through what that does. So I'm going to go ahead and just work with this file. So we saw it a minute ago. It's this giant document. Let me zoom in. Let's ask it a question. So I'm going to ask it to find every section heading that mentions broadband in this bill. The word broadband is a specific match. It's going to go ahead and search across that document. So this is not the pulling all of that into the model, but rather it's going to leverage a tool to search across that document and then give us the results. All right, results are in. Found one section. It's got the word broadband in it. And so you can see we got the exact answer using a match from that large document. But now I'm actually going to use something that's only available here internally to me as a member of the team, but I can actually look at the size of the context window that was leveraged in this query. I just want to show that here I am using GPT-5.4 and I only used 42,000 tokens. And so again, working with that giant document with a constrained window, no problem. So now let's try a different question. We're going to go ahead and ask, what does this bill say about funding for rural internet access? And so for this, we're going to go ahead and actually do a match tool. So this needs semantic matching because the words rural internet access are not things that I can search for in the document and attempt to find. And so this is going to use search and semantic matching to answer this question by reasoning on the index that's been taken of this document. All right, the results are in. We can see that it says rural broadband is a major funding priority and it gives some information. And so the way that it did this is actually by, again, using those tools like cat file and digesting parts of the file as well as a grep to try and search. So it's using a set of tools available to it to try and answer the question. So we were able to get our answer by using a set of tools to search across that content. All right, let's do our final test. So we're going to go ahead and actually do what seems overly complicated for a document of this scale. Break down this bill by division. How many sections are in each division? How many pages does each one span? So this is going to produce a structural table of contents. And that seems like something you could only do by reading the entire document. But now what we're going to do is we're actually going to pair those document-related tools with code. So again, I'm not reading all of it into the LLM model, putting it into context. The model's writing code, running that code on the outputs of the document here locally inside my browser, and then the output of that result is what will end up on screen. Let's give it a second to run. All right, our results are in, and we can see here that it has gone ahead and processed this. So I have division A through I which matches what I expect to see with their title, sections, pages, page span broken out. Okay, so let's go ahead and jump into the explainer and just sort of talk about what we saw. So one architecture, multiple different entry points or different tools that are used to answer different types of questions. And so if we know what tools there are, we know what types of questions we can ask. So there's 3 patterns we talked about. One is keyword search. This uses the cat tool, which takes search within a document or dumps a set of text within a document out, but it doesn't actually put the text into the LLM context window. Rather, it puts pointers into the window. And so you can take that and then do things like grep, which is essentially in-document search. You can you can dump it into semantic search for pattern matching. We use this for that a rural broadband question, or you can take the results of the file and you can actually put it into code execution. So that's how we find the different sections of the document and maybe count how many there are. And so this means there are a set of queries that work really well with this tool-based architecture. Find needles in a haystack, like finding every section that has a word in it, counting and aggregation, things like structural questions about the file itself. Conceptual questions also work well because you can find passages by meaning. So that's where we did the rural intranet with some pattern matching. But there are also things that don't work well. And so you want to be really careful about these types of things because you're sort of hitting at the limitations of this tool-based model. Tables and structured layouts can be tricky. If you ask for funding table in section 203, that can be tricky. And sometimes some LLMs are better at it than others. There are things that we do in Microsoft 365 to actually take screenshots, for example, if you ask for a table on a slide deck, where we actually have a screenshot of the slide. Those types of things allow us to work around some of these limitations, but those are the tricks you have to watch out for. Exact page references. You saw it here in this demo. When I said pages, wait, 450, it's not the right amount. Well, the definition of a page, when the LLM looks at the PDF, it does not actually open up the PDF and see every page. It gets a dump of the text inside of it. And some of that text is structure, and we strip a lot of that away. And so the actual file that the LLM has is not the file that you see in the viewer. And so the result there is often confusion. With things like PowerPoint, the definition of slide 3 is still the definition of slide 3. When it comes to a PDF or something of that sort, especially like a Word document where font size, all those things are different. Definition of a page is not necessarily the same. Cross-document reasoning, the tools, that can be tricky. Sometimes some AIs are better at this than other. I highly recommend this is where you want to do evaluations and really think about your question. Some harnesses are really good about digging into that next layer question. We do a lot of evaluations here in the SharePoint team to actually understand sort of these 2 or 3 step type problems. But if the question you ask can only be answered by first reading document A, understanding a next layer of complexity, and then asking that question of document B, one, you have to be in a harness model, a traditional chat-based, your Claudes, Copilots, etc., won't understand these 2-step models because they're single-shot experiences. But it gets shaky, and you really want to test this and validate your question, and then summarize the whole thing. You will get an answer from the AI, and so these are all not things that necessarily don't work. These are things where you have to be careful. And so when you ask it to summarize the whole thing, if there's a table of contents like this file I had, actually it can use that really well to try and understand the process. And so really be thoughtful about the question. And if you ask it to summarize the whole thing and ask it to answer a very specific question, that question might not be something that was in the context because you just can't read that whole file into context. So be specific, not sweeping. Those are sort of the really broad statement I would make in terms of how to make large files work for you with AI. Narrow questions really help. And so just some examples here, and I wanted to sort of show how this all comes together with some of our internal tools, but it really applies to whatever work you're doing with a harness-based AI system on any platform. Thanks for watching.